right, so the first thing that I want you to do is we are going to make a foldable. So on your table, you will see a blank sheet of paper. You're going to hold it just like you would write with it, so long ways, and then fold it over just like this. Crease that so it's long, okay? Fold it up. So you have that right there. Fold it up one more time. And then when you unfold it, you are going to have 4 rectangles just like that. So on the very first rectangle, I want you to write the word opposite. On the next rectangle, I want you to write absolute value. Then integers. And then the last one, rational numbers. Okay, so take the scissors that are on your table, open up the paper, and then just cut that, that door just like that. Notice I did not cut it all the way through. It's just so that the door will open. So you're going to cut that one. Again, hold your paper open. That one and one more cut right here so that you'll have the 4 different doors that will open. As we're writing, this is where the definition will go, and this is where our example will go, okay? And then when we're completely done, what you're going to do is you're going to fold that up just like this and put glue just on this back side so that it'll go in your journal like this where it folds down so you can open it all back up. So let's go to opposites. So open up the door opposites, and I want you to write the definition for me. The definition that you are going to write is 2 numbers that are an equal distance from 0 on a number line. Okay, and then so our example, and again, you can pause the video whenever, if I'm going too fast, you pause the video so you can keep up and then rewind it. That's the point of it being on a video. So our example is you're going to draw me a number line right over here. We know that 0 is always going to be in the center there, or it's in the middle. So if I did over here 1, 2, 3, 4, 5, right? And I don't have to label all of those, but that's 5 because it's 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. And then if I went this direction, 1, 2, 3, 4, 5, this would be -5 because if I go from 0, 1, 2, 3, 4, 5 in the opposite direction. So here's 0, okay? They are the equal distance. 5 jumps this way. The opposite would be 5 jumps this way, which would be -5. So the opposite of 5 is -5, or the opposite of -5 is 5. Okay, good. Close that door. Open up absolute value. The definition that you're going to give me for absolute value is the distance of a number from 0 on a number line. Okay. And so I want you to put right here in these brackets or whatever, no negative distance. So guys, even if I am, let's say I'm running backwards, I'm still running, okay? If I'm driving my car in reverse, I'm still going a distance. I can run backwards a mile, I'll probably fall, but I could do it, right? And I'm still moving a distance. So no matter if you're going forward, backwards, sideways, left, right, you're still going a distance. So absolute value is the distance you are from 0. So what that looks like is it's going to be these symbols, little like goal lines right here. And let's say I put -5 in there. Well, how far is -5 from 0 on the number line? Well, it's really just 5 hops, which we talked about up here. It doesn't matter that it's going left or right. It just matters that it's 5 hops. So these lines right here mean absolute value. They mean distance from 0, right? Okay. All right. Open up your third door, which is integers. And integers is a member of the set of whole numbers and their opposites. Okay, so we know since, I don't know, second or third grade, that whole numbers are the numbers we count with, right? Including zeros. So whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Now, counting numbers don't include 0, but whole numbers, all those numbers, not numbers with decimals and numbers behind the decimal, but whole numbers like 1, 2, 3, 4, so on. Integers include all of your whole numbers and their opposites. So for example, if I go 0 and then I say 1, 2, 3, those are whole numbers, right? So, and their opposites, there's no opposite of 0, 0 is 0. But the opposite of that 1 would be -1. So that's an integer. The opposite of this 2 would be -2. So that's an integer. The opposite of that 3 would be -3. So that's an integer. So guys, they go on forever, but it's all your whole numbers. Remember, whole numbers go on forever, and their opposites. That's what integers are. Okay? So it's whole numbers and negative whole numbers. Okay, open up your last door, rational numbers. And I want you to write the definition. A number that can be written in the form A over B. Guys, that A and B, all it means is written as a fraction. A number over a number. Okay, that line means divide. So A over B, where B cannot, that means not, be 0. B has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. It just can't be 0, okay? So what this really means is a rational number are numbers that can be written as fractions. Can be written as a fraction. Just sounds fancy when you're talking about A over B, where B can't be 0, but this is what it means. Okay? Put that in brackets for you. So over here, if I give an example, let me give you the number 3. Is 3 a rational number? Can I write 3 as a fraction? Yes, because I can make it 3 over 1, and those are equivalent. Those are the same thing. It's a fraction. Now it's A over B, and B is not 0. So 3 is a whole number. We know it's an integer, and it's also a rational number. Okay? What if I have, let's see, 0.75? Well, we know that 0.75 is not a whole number. So it can't be an integer, but it can be, written as a fraction because it can be 75 over 100 because that 5 is in the hundredths place. Okay. And then the last one, like -2/3, that's already written as a fraction. So Again, all of those can be written as a fraction. So again, what you're going to